Okay, so we are at 12:30, and so now we're welcome you to this next session on panel 9 on product appliance ICT. And in particular, welcome to the point of product regulation, market surveillance, and monitoring. My name is Thomas Götz from Wuppertal Institute, and I will coordinate this panel for today. And so welcome to the audience and our panelists. And yeah, as we have a very tight schedule for today, we have 50 minutes for presentations and 5 minutes for short answers directly after the presentations, as well as a bit of time for discussions afterwards. We start quite immediately, but before, some general remarks to the audience in particular regarding asking questions after the presentations. Please use the Q&A function of WUFA so that the presenters get your questions and can prepare after the presentations to answer your questions. Okay, so then after this first introduction, let's directly start with our first presentation of the day. And this will be given by Kyriakos Papazoglou. And he is project officer, program officer at ProSafe, the Product Safety Forum of Europe. He holds a PhD in International Economic Relations and Business Development. And before, he acted as a project manager and expert on numerous projects, in particular also in the context of European funded projects, in the context of appliances and respective products. And in this context, he will give us a presentation of modeling energy and non-energy impacts on product non-compliances and the results, especially from the E-Pline 2 and 3 projects. And therefore, I hand over to the presentation of Kyriakos, and so please start the presentation. So maybe to Carol, a remark, I cannot hear the presentation. I can only see it. Can you please check the sound?
Hello, it's a pleasure to be here. The case we unfold today is why the quantification of energy and non-energy impacts of product non-compliance can influence social and consumer behavior towards sustainability and support energy policy innovations in the European Union. For this, we will use the examples of two EU-funded projects, the E-Pline 2 and the E-Pline 3 joint market surveillance actions. For start, let's praise a bit ourselves. The European Union has already achieved a lot as regards energy efficiency. We have done a tremendous progress in this field in the past 10 years. However, still the level of energy consumption is not in line with the EU's ambition for decarbonization by 2050. Because of this, the transition to a net zero carbon economy is a pressing strategic challenge and at the same time a multidimensional problem. In the EU, Ecodesign and energy labeling account for over 40% of the 20% energy efficiency target and 23% of the greenhouse gas emission reduction target for 2020. Today we know that improving the energy performance of appliances is one of the most effective ways to reduce electricity consumption and mitigate climate change. In recent years, research and practice have shown that energy efficiency is a case not only for cost savings and greenhouse gas mitigation, but also for improvements in human health, the environment, and social welfare, with a lot of positive stimulating effects on the economy. An omission of all these multiple impacts in cost-benefit analysis reduces drastically the cost-effectiveness of energy efficiency improvement actions below their actual value, and because of this, it leads to underinvestment. With nearly 550 billion euros in the pipeline to be spent on climate investment according to the current EU budget for the period, this matters a lot. So the quantification and the use of impact data in data aggregation and policy evaluation models are of key importance if we are to support better decision making and increase the attractiveness of public and private investments in energy efficiency. But if evidence is there, Why the buy-in for energy efficiency is still difficult, slow, and variable. What do we miss? In an attempt to answer this question within the e-Planner program, we detected three main pain points. First, we have come to realize that we need a better understanding on what drives energy efficiency transformation across the board, taking into account all possible constraints. To give you a small example, today new technologies and digitalization yield tremendous technical intelligent efficiencies because of the high level of control, optimization, and analytics that enable the benefits of energy efficiency to be measured and valued quickly and accurately. However, the success of these technologies in the market largely depends on the ability and the willingness of the consumer to deal with a new technology. Second, we need evidence, better evidence in the sense of more reliable, quick, and easy data, not necessarily more data. This can help bridge a gap, as the causal link from investments to the impacts of energy efficiency is often very complex and indirect, so the effects cannot be seen immediately. Last but not least, we need better, more effective, more attractive supporting narratives that go beyond the facts. In this context, what is ePlan 3 and what it tries to achieve? ePlan 3 is the third project in a series of three large-scale cross-border market surveillance joint campaigns on eco-design and energy labeling, all led by European market surveillance authorities since 2015. The goal is shared: to detect greenwashing and free-riding non-compliant products placed on the EU market and enforce compliance. The method used is monitoring, verification, and enforcement. This involves product inspections, online screening, and compliance laboratory testing. The process is not necessarily perfect, but is sufficient for delivering good results. Here is the panorama of ePlan 3. The project is expected to run until November 2023. 29 partners, out of which 24 market surveillance authorities for 21 European countries, participate in 12 work packages, 6 so-called horizontal work packages, and 6 product-specific. Here you can see the 6 specific product sectors targeted by ePlan 3. So what is the fundamental problem that ePlan 3 tries to deal with? The fundamental problem for energy efficiency in general is that because of market and regulatory failures and barriers, a large amount of energy is lost. This is confirmed consistently by the results of the entire ePlan program. The results exhibit overall serious and consistent high levels of product non-compliance. In ePlan 2, the average test failure rate for the 3 targeted product sectors was almost 40%. This means that 40% of the products tested by ePlan 2 were found to have excess energy consumption. But what is the gravity of the problem? Well, before we answer this, let's have a snapshot on the results of ePlan 2 per product sector. At the bottom, you can see the individual failure rates of its product type. These are the household refrigerating appliances, the network standby appliances, and the professional refrigerating appliances. It is important here to stress that the results cannot be considered representative of the market as a whole, and this is because of the sampling methodology used. The sampling of the products was based on filters used by the inspectors by means of risk-based criteria. This is one of the main reasons why it would be risky to extrapolate these results to the market as a whole. So, why and how much product non-compliance matters? This question led ePlan 2 to design a model in order to estimate the impact of non-compliance in terms of electricity, CO2 emissions, and the economic impact of lost energy. Here the graph depicts a simplified version of how the model works. The model combines a series of data points as input data in order to estimate the overall energy consumption of compliant and non-compliant products in the EU market. These data include the average lifespan of product, past, current, and future sale volumes, the market distribution, the detected compliance rates, the energy consumption per mode of use, and usage profiles. After a series of calculations, the model produces two main scenarios. First, we have the reference scenario, which is the market, the energy performance of the market as it is, with the mix of compliant and non-compliant products still traded in the market. The second scenario is the market efficient scenario, which calculates the energy performance after the applying to control and enforcement activities, so the energy that would have been consumed by the product types targeted by applying to if the market was 100% compliant. Here we see in more detail what the model calculates. So it calculates the lost energy because of the non-compliant products, the energy savings achieved because of the removal of these products from the market, the financial impact for the consumers, the primary energy factor with a comparison between the two main scenarios, the annualized energy savings per product sector until 2030, and the monetized gross savings per product sector, all these before and after applying to activities. Unfortunately, similarly to other impact models, our model has its own inherent limitations. And these are because for applying to, we had to rely largely on incomplete secondary data sets. These were market data that we managed to gather from open sources. These include reports from the industry, press releases, impact assessments, all kinds of third-party open sources that contain incomplete and sometimes outdated data. This led us to perform informed assumptions and data projections that are subject to a certain degree of uncertainty. Here is an example of the estimated energy use of the product types tested by applying to Work Package 5, focused on network standby appliances. The red line here shows the actual energy used by the product types tested under applying to Work Package 5 activities, meaning the market performance as it is, with the mix of compliant and non-compliant products in the market as a whole. In contrast, the green line is the estimate of the energy that would have been used if all individual models of the product types tested by applying to Work Package 5 and sold in the EU market were compliant with the network standby regulations. And here are the results of the potential aggregate energy savings by 2030 because of applying to. As you see, the results for the individual product sectors suggest that there is a significant amount of lost energy resulting from non-compliance. Again, these are indicative estimates and should be used with caution, but still they provide a good indication of the scale of the problem. So the primary energy loss saved as a result of the applying to refrigeration activities alone is estimated to average 80 gigawatt hours per year for the period between 2020 and 2030. This is a gain of almost 100 million euros in aggregated reduced energy cost for the consumer. This assessment assumes that the overall rate of compliance in the domestic and professional refrigeration sectors alone improves by a very conservative 1% due to the enforcement activities of applying to. On the other hand, the cost of repeating the same market surveillance exercise on a biannual basis for the next 10 years would not exceed 5 million euros. So what we were missing in applying to, as we already said, we were missing complete accurate, and up-to-date market data. These limitations have helped us rethink our strategy in Epline 3. So what is different in Epline 3? In Epline 3, we purchased complete sets of market data that allowed us to overcome all these previous data limitations. With this, we will manage to estimate with a high degree of reliability the direct and indirect impacts of the concerted action. And we will do so without having to rely so much on educated assumptions, at least to the degree that we have done so under Epline 2. So we will put real, reliable numbers behind the direct impacts of the project. This upgraded Epline 3 model will be a credible forecaster for improved decision making, a tool that can help support policy design and bridge the gap with the reality in the years to come. But we have come to realize also that facts alone do not motivate people to change behavior and improve their decision making. We have the facts, now we need the narratives. Stories serve many wonderful functions. They teach, they motivate, they inspire. Our perception of the world is not based on statistical facts, but on the stories of how these facts are told in order to help us make sense of the world. This is why our brain is craving for narratives. And this is why we have this ambition to harness behavioral insights in order to create simple, internally consistent, and emotionally coherent stories for the different actor groups based on our evidence. Studies have shown by and large that interventions suggested by behavioral economics and social psychology tend to work. So the idea for us is to apply in our communication efforts techniques of the psychology of decision making and behavioral economics. For example, the notion of choice architecture as built into nudging, in order to make it easier for people to choose what is best for themselves. However, it's essential to remember that these are limited and simple interventions. Nudging makes it easier for people to make some decisions rather than others, but nudging by itself is not going to solve climate change and energy efficiency problem. There is a range of employable levers if we are to improve our energy footprint, and for sure coercion must be involved. Anyhow, this will be a long run. It's work in progress. Stay tuned. Thank you.
So yeah, thank you very much, Kyriakos, for this presentation. And I'm having already a look at our Q&A section, and at the moment there's no question from the audience, but for the time the participants you can think about some questions. I have two questions to Kyriakos. And Kyriakos, are you still there?
Yes.
Cannot see you, at least as a video. If you like to turn on your video again.
My camera is on. I hope.
Oh yes, now I can see you. Perfect. Maybe it's just talking. Yes, my first question to you, a very interesting topic, would be, you said you have to create narratives for different target groups, but in particular, of course, have you talked to decision makers, policy makers, especially, for example, on EU level, and confronted them with your results? This would be my first question. What was their reaction on this quite challenging results, because so high levels of non-compliance? And then my second question would be, how would you plan the continuation of the e-Epline projects and how it is linked to future policy making? So these are my two questions, please.
Thank you, Thomas. Again, it's a great pleasure being here today. So to answer your first question, yes, all stakeholders and all interested parties are aware of these results. These results have been transparently communicated in our public reports, and also we communicated them at the final conference of Epline 2. Again, as stated in the presentation, these results should be taken with a certain degree of caution because of the informed estimates that we had to rely on in order to deliver. These will change in Appliance 3. We have managed to obtain, to buy complete sets of market data that will allow us to perform better, reliable, and more accurate data projections with regards to the direct and the indirect impacts of non-compliances, of the non-compliance that will be detected in Appliance 3. So yes, this is something that the impact is something that we certainly pay a large attention to, and this is also something that we try to integrate as much as possible in our communication. As we gather that it's not enough to have the facts; it really matters how and to whom you communicate them. Your second question, I think, was about policy feedback from the project. And indeed, also, this is a very important aspect of all Appliance projects. As happened in the previous Appliance actions, the Appliance 1 and the Appliance 2 joint market surveillance actions. So similarly to what we've done then, also the Appliance 3 concerted action intends to feed with policy recommendation to the European Commission, but also at the national level, in order everybody to be able to adjust policies and design the best possible policy package for the future.
Mm-hmm. Okay, thanks, Kyriakos. I see we have one more question. We have short time for it. As you've seen in the question and answer section, have you identified complementary activities next to market surveillance that would increase compliance?
Yes, we do. However, I'm afraid these are outside the scope of the current project structure. So yes, we have a lot of ideas that could complement the core market surveillance exercises and campaigns that we conduct in Appliance 3. As much as possible, we try to incorporate such ideas and put them into our work plan and execute them. However, as said, we have certain project constraints that we have to respect. So, in short, yes, there are a lot of complementary ideas that we have and activities, particularly with regards to communication. We try to incorporate, but also always we have to mind our project constraints.
Mm-hmm. Okay, thank you very much for answering this question. Also, with having a look at the time, the remark again, you can, of course, from the audience have more questions later on at the end of the panel sessions. But for now, we say thank you to Kyriakos for answering the questions. And yeah, maybe looking at back later on. And now I will hand over then to our next presentation. And this will be given by Katrin Graulich. She is a deputy head of sustainable products and material flows and senior researcher at the Ecodesign in Germany. For many years, she has, of course, a lot of experiences in sustainable consumption, production, and policy concepts, in particular in the context of eco-design and energy-related products. And there she is also currently the project manager of the Horizon 2020 research project ANTICSS, or anti-circumvention of standards for better market surveillance. And from this project, she will present us the results, in particular impacts, mitigation measures, and recommendations for policy and standardization. So therefore, I hand over to the presentation now. And yeah, please start the presentation.
Welcome to my eceee presentation on circumvention of EU eco-design and energy labeling regulation and standards. I will present you some very interesting results of the ANTICSS project a study funded within the Horizon 2020 program of the European Commission. The study is led by Öko-Institut in Germany, and I'm Katrin Graulich, the Deputy Head of the Sustainable Products and Material Flows Division at Öko-Institut and the ANTICSS Project Manager. Our study team consists of 19 partners in total of 8 countries, and we are several research organizations, national energy agencies, standardization organizations, but also test laboratories and market surveillance authorities. Aim of the ANTICSS project is to provide a clear definition of circumvention under EU Ecodesign and energy labeling legislation. Also, we developed alternative test methods to better detect circumvention, and we made an impact assessment. That means we calculated the potential energy losses that might be possible through circumvention. And based on the results, we made capacity building measures and guidelines for market surveillance authorities and test labs. And currently we are developing recommendations for policy and standardization to better detect and avoid circumvention in future. When we started the ANTICSS project in 2018, there was no clear definition on circumvention in ecodesign and energy labeling legislation. Only later in the Ecodesign regulations adopted in 2019, these included an article on circumvention. It says that the manufacturer, importer or authorized representative shall not place on the market products that are designed to be able to detect they are being tested. For example, by recognizing the test conditions or test cycle, and that react specifically by automatically altering their performance during the test with the aim of reaching more favorable results for any of the parameters declared. In ANTICSS, we started with collecting suspicious cases. We did this through a literature review and through a stakeholder consultation. And by this, we found about nearly 40 suspicious cases, and we clustered them and categorized them. And we found that the act of circumvention might not only be by automatic detection of the test situation and automatic alteration of the product performance during the test, which is currently written in the Ecodesign regulations, but that circumvention could also be done by preset or manual alteration of the product, which also can affect the performance or resource consumption during the test. And a third option that we found could be possible is that the alteration is preset. The alteration does not take place during the test, but only within a short period after putting the product into service. Besides these 3 types of circumvention, we also found acts that might not be classified as circumvention and might not be illegal, but that become possible due to loopholes or weaknesses in standards and regulations. And we call these jeopardy effects. That means all those acts where manufacturers exploit the loopholes and weaknesses of the standards and regulations to get an advantage and get more favorable results. So for the reported cases, the collected suspicious cases, we differentiated between hints for circumvention and jeopardy effects. Hints for circumvention were those cases which were specific only to the test situation. For example, specific test instructions which were exclusively provided to the test laboratories, or hidden software which was only reacting to the test situations. On the other hand, the jeopardy effects, we categorized those cases which were applicable both in the test situation and during consumer use. But for the consumer use, this was very rare and extremely infrequent. And only theoretically possible. So for example, specific test instructions, which were also included in the user manual, but which will not be used by the consumers, or smart functions which were specifically applicable in the test situations, but not so much during consumer life. We also found that circumvention is much more than just non-compliance. So non-compliance can be determined by market surveillance authorities through product inspection, for example, by laboratory testing according to harmonized standards, and checking the data and information provided in the technical documentation, and check if this information complies with the requirements and conditions of the legislation and standards. So in contrast, circumvention and jeopardy effects do not make a product appear as non-compliant during the testing according to harmonized standards. So the tricky thing is that in the first instance, products appear to comply with all these requirements and conditions. But this is because the test results are specifically influenced, and they result in more favorable for the manufacturer by using this circumvention behavior or by exploiting possible weaknesses and loopholes of the standards and legislation. This means that the harmonized test standards that we have, that they are often not useful for detecting circumvention, and we need alternative test procedures. And in ANTICSS we developed for a couple of product categories alternative test procedures to address and detect circumvention behavior under testing. The aim was that these test procedures are very closely to the standard test procedures, but with very slight adaptations of those aspects that are related to the suspicious behavior. So we compared then the results of the harmonized standard with the results of the alternative test procedures. And we used the verification tolerances of the legislation for assessing the significance of the deviations. And if we saw that there are relevant performance changes, then we say that the hints on circumvention or the jeopardy behavior might be confirmed. That means when we tested product models and followed the path on hints for circumvention, and we see that they have more favorable results under the testing, the specific models, then we categorized them as circumvention. On the other hand, for those cases which we categorized as jeopardy effects, when we tested certain product models and we saw under the test that they have more favorable results, we did not call them circumvention, but borderline to circumvention. The first example I would like to present is on washing machines. Washing machines might be optimized specifically at the two testing points at the declared full and half load that are used according to the harmonized standards, whereas the consumption values could follow a different pattern when the machines run at different loads. We tested once with the harmonized standard, that means 2 test runs at half load 40 degree, 2 test runs at half load 60 degree, and 3 test runs at full load 60 degree. It was a 10 kilogram washing machine, that means 10 kilogram full load and 5 kilogram half load. And for the alternative testing procedure, we used the same 7 treatments, but with full load 6 kilogram instead and half load 3 kilogram instead. For one of the models, we found a suspicious behavior, and therefore we tested additional treatments at 60 degree. So we tested in addition also 4 kilogram, 6.5 kilogram and 8 kilogram. The results were astonishing. So here you see that at the declared full and half load, 5 kilogram and 10 kilogram, we have the lowest consumption values, and for the lower capacities at 4 and 3 kilogram and at 8, 6.5 and 6 kilogram, we each have higher consumption values than for the declared values. And we also see a rather striking increase between 5 and 6 kilogram of the consumption values. We could categorize this tested model as borderline to circumvention, assuming that the more efficient test results for the energy consumption at full and half load capacity would also be achieved in real life when the consumers load the machine around these capacities. Or we could categorize this tested model as circumvention, imagining that the model could have a sensor that automatically detects the weight of the load, and if the weight corresponds exactly to the load used in the standard tests, the full and half load rated capacity, the energy and water consumption would be reduced exclusively under these standard test conditions, but not in consumer use. We found further examples of circumvention or borderline to circumvention. For example, a dishwasher model with specific instructions that were exclusively provided to test labs, with the instruction to alter the position or even remove certain racks, split the cutlery basket and so on, to reach the declared capacity of 16 place settings. No information was provided in the user instructions. That means without these specific changes, the dishwasher as supplied to the consumer can only be loaded with 12 place settings instead of 16 place settings. We found a refrigerator model with a display, a clock, that was nearly always on in normal use, and it was programmed to turn off only after 24 hours of no door openings, for example when you are on holiday. As the harmonized test standard is without any door openings, the display is turned off under test, and its additional energy consumption is not considered for the overall energy consumption and energy label. We found an oven model with specific recipes, for example for making yogurt, in the user manual, that provides the basis for the standard testing that the shelf guides and side racks have to be removed under standard testing. That means the oven volume increases, and the oven volume is a parameter of the formula for the calculation of the energy efficiency index and the resulting energy efficiency class, which could be improved by increasing the oven volume. Also for ovens we found another model, and for ovens you have a decoupled energy and temperature measurement in the standard test. And during the energy measurement, the set oven temperature of 190 degrees dropped to 90 degrees. That means you have a lower energy consumption. Whereas during the subsequent temperature measurement, the oven temperature remains stable at the set 190 degrees. And we found a television model with a backlight reduction function. That means also reduced input power. And this backlight reduction function was at extremely fast moving images as are used in the standard test video, but these extremely fast moving images hardly never apply in real life broadcasting content. Based on these results, ANTICSS has following recommendations for policy and standardization. Extend the legal definition of circumvention, which is currently in the Ecodesign and energy labeling regulations, to cover also the further types of circumvention that we found within ANTICSS. Make possible the use of alternative test methods that aim at indicating the presence of circumvention. Avoid the misuse of the manufacturer's instructions for laboratory testing. Develop harmonized standards as close as possible to average real-life usage of products, And finally, analyze the application of legislation at regular intervals to identify jeopardy effects, loopholes, and other weaknesses that might facilitate circumvention. The identified loopholes should be overcome via a fast-track revision procedure of the legislation, as we know that the regular revision process sometimes takes a couple of years. Thank you very much for your attention.
Yeah, thank you very much to Katrin for this very interesting presentation. And accordingly, we have already some questions in our chat. I'm scrolling already. I think, Katrin, also you answered some in chat, but for the general audience, it would be good that you could repeat more or less your answers. And I think the first question was on the product groups which were looked at and how they could be affected. And the second one, there was a specific question to the washing machine. I think you can see it, right?
Yes, thank you very much. Indeed, we started with all product categories in scope of the Ecodesign and energy labeling legislation. But for the testing, we selected 8 product categories, which are put in the chat. And your question was if some of them are more prone to circumvention or not. And our findings are that in principle, these kind of instructions or also these, if you only have 2 testing points and then you play around these 2 testing points, in principle, this could apply to all product categories that use such kind of tests. So I won't say that some product categories are more prone or others not. And for the impacts, yes, indeed, we did an impact assessment, and also, as you already said, it could be that the clock of the refrigerator, that the power consumption is not that much. But if you imagine that all refrigerators on the market would use more and more such sensors and such displays, which are not accounted for the energy consumption and the energy label, then it would also make an impact. So it always depends on how much such acts could also be applied by other products and how widespread these kind of acts could be. But we have on our website made the impact assessment. And the final question I just see, or the third question, is how widespread these effects are. We did not, so for 8 product categories and in total 18 different kinds of suspicious behavior, we analyzed each 3 models. We also made a targeted modeling selection to find circumvention indeed. And in our impact assessment, we made 3 scenarios, a very conservative scenario, but also a very extensive scenario where we say how much impact could be if any of these appliances that are technically possible would apply such circumvention behavior. And if we think that they copy such acts, it could be widespread, but I would not say we found a very widespread use of such behavior.
Okay, thank you. I see we have one final question in time, really only for this one final question at the moment and it's on, more or less on manufacturers, if there are special manufacturers which are very obvious in this context.
I won't say anything on that. And also, I think it's not the aim to blame and shame, but it's more to just, as you say, to show how manufacturers might use this legislation. And but just to say, it's not only maybe low-level manufacturers. It could also affect the well-known. The well-known manufacturers. So, but we won't blame anybody on that in the first instance.
Okay, on the first instance. Okay, yeah, I think so far, I think looking at the time, I think we have answered the question. We could come back later on again, because I think we have several in this context. Therefore, thanks again for Katrin for this very interesting presentation. And then we go on to our next presentation, which will be given by Sophie Attali. And of course, Sophie is very well known here as being a part of eceee and also a consultant of So What and Gaia Top 10. And she is an expert with more than 20 years of experiences and worked in many projects in this context, of course, with context of product policies, European institutional policy frameworks, demand side management, and general institutional capacity buildings for different contexts and audiences. And her presentation will be in particular on the usefulness of sales data to understand energy stakes for appliances. Therefore, please start the presentation.
Hello, I am not Teres Kreitz. She apologizes, but she couldn't make it today. I'm Sophie Attali, and I undertook this study together with Francisco Zuluaga. Actually, we call this study a market monitoring study, and we've already done 2 of these together with Top 10 EU in 2016 and in 2014. And this one and the one previously had been funded by ADEME, the French Agency for Energy Transition. What we want to do with these market monitoring studies is to make explicit market evolutions by publishing regularly consistent data over time and geographically. So our objective is really to make an observation of the situation and put the information on the table so that the results can be used by other teams to try to confront them with policy goals or make further studies to explain these results. We are based on data until 2019 included, that is before the introduction of the new energy label and also before the COVID crisis, so our data do not show these 2 issues. We also used data from the energy label, that is data declared by the manufacturers on the label corresponding to standardized measurement protocols, not to actual energy consumption, etc. So what we did is we bought some sales data to a global marketing company called GfK, and we bought it from 15 years, from 2004 until 2019. We bought it for Europe 21, that's an average of the 21 countries followed by GfK over all these years. We bought it also for single countries, France, Germany, Italy. We bought it from refrigerators, washing machines, and tumble dryers. And we bought the information concerning energy class, volume or capacity, energy and water consumption and prices, and the rest we calculated. So this is really sales data. It's different from the data that we can find in EPREL. EPREL is the European database for products that are covered by the energy label. And inside, it's the suppliers that put their products in the database. It doesn't mean that they will necessarily be sold. And actually, we know from other countries that have similar databases that a lot of products that are in these databases are actually never sold. So what is offered on the market doesn't equals directly to the sales. We did a long report with a lot of graphs, so I advise you if you want to check it out, because now I'm just going to give some highlights that we have chosen, maybe a bit longer for the refrigerators. So for the refrigerator, this slide shows clearly the impact of the energy regulations that were introduced in Europe. And we have calculated for refrigerators an improvement of 40% of the energy efficiency index. What we see with the energy consumption, this is the average, it also impressively reduces. However, it reduces only by 27%. So we can wonder, where does this gap come from between 40% energy efficiency and 20% energy consumption? There are several hypotheses. Of course, one is about the way the regulations are constructed and how the formula are built, because Actually, in Europe, there are some bonuses for some products, like built-in products or products that have a tropicalized compressor or products that have the frost-free functions. They are allowed to consume more for a same energy efficiency index. So, of course, the energy efficiency index seems good, but the consumption is not as good. Another issue is that the volume has raised during this period, not enough to explain all this gap. So I think it's 9% of volume in 15 years, but 15% for the freezer compartment. And I forgot to say that what we call refrigerators include fridge freezers, but not independent freezers. If we get into the details, we can actually see national differences. So here you can see the 3 countries and the European average, and we can see that very consistently Italy consumes more than Germany. That is, the Italian consumers and the German consumers choose products that consume more. There is a 30% difference in the last years, and this is quite important in terms of kilowatt hour, because when you know that there is 1.5 million models sold in Italy last year in 2019, and 3.2 million in Germany, and 17 million in Europe as a whole, it makes really an important difference in the electricity consumption in the end. However, we must go a bit deeper. If you look at Italy with these 250 kilowatt hour consumption, it is not necessarily because they are not efficient. As you can see on this graph, with EU on the left and Italy on the right, actually Italy has a market penetration of good energy classes higher than the European average. So it's rather because the Italian models are bigger that they consume more. Actually, the French situation, the second bar, is pretty bad because the best classes make up 20% on the market, whereas, for example, in Germany, they make up 75% of the market, 76%. So it always amazes me how Europe has the same regulation, the same suppliers able to supply all countries in Europe, and however, we have these national preferences and differences that show in our numbers. If we go a bit more in the details and look at the prices per classes and per country, we can see that the logic is respected in the sense that the A+ models are less expensive than the A++, which are less expensive than the A3+. And we can also see that Germany has always the lowest price. Okay, it's not that obvious for the A3+ models, but it's still the case. And you can see that it's no surprise that in France it's very difficult to sell A++ models because they are much more expensive, not only than the other classes, but also than what happens in the other countries. So here maybe there is an issue between the marketing policies and the readiness to pay from consumers. And I hope that some studies will tell us which one of the influences the other. Because very often we hear, oh, consumers are not ready for this. And on the other side, we can hear, well, there is no supply of good and reasonably priced efficient appliances. And finally, another way of looking at this is looking at the total cost. So the price plus the electricity cost over 15 years. And here you can see for refrigerator that, of course, A+++ appliances are always good for the planet. You can see in blue the energy consumption that is really much smaller for A++ than for A+. However, it's kind of neutral, if not bad, for the wallet because of this total cost and this very high purchasing price. So, of course, it costs more to make a more efficient product because for a fridge you need a better compressor, more copper, you need more insulation materials, okay? But this doesn't justify such a difference in the price. You can also argue that these products are not more expensive because they are energy efficient. They are more expensive because they bear all the attributes of the high-range products. So they will have glass instead of plastic and stainless steel, for example. I would also argue that there is a problem with the marketing positioning that interferes, and it makes it really difficult for consumers to get convinced that they should invest in energy efficiency. But also it means that for energy advocates, maybe it's time to change messages and to explain to people that sometimes energy efficiency and to reduce energy consumption may cost more, all in all, over time. Because, I mean, we really collectively, we really need to get these savings everywhere they are. Now, if we go to the washing machines, this very basic information shows that it was high time to revise the energy label, because already in 2016, the market was more than 80% with the best energy classes. Also, I'm not going to show it here, but the energy consumption has gone down in the same proportions, whereas at the same time, the capacities have really grown a lot, because 10 years ago, I think the 7 kilos and more made up not even 30% of the market, and now they make up 80% of the market. However, there are very small differences between classes, and this is explained because the energy label is constructed in a way that doesn't differentiate very much each energy class, but also because the best classes are bigger. This, I think, is very confusing for consumers if they knew about this, because in the end, the A++ classes on average consume more than the A+. However, the average load that people put inside the laundry, they put inside their washing machine, to our knowledge hasn't changed that much, and it's still around 4 kilos. If we look at the national differences, this is far less obvious than for fridges, and you can see that it's almost equal between the countries. At the beginning, when the introduction of the label, it wasn't the case, but now it's okay. This is the average energy consumption. And if we look at prices, however, we can see that the German price for A++ model is very high. It's almost €100 more than in France. But however, it doesn't stop German consumers from buying A++ models, because in Germany, this energy class is 92% of the market, whereas in France it's only 70% of the market. So here again we can see that there are cultural differences that are exploited in different ways by marketing strategies. Again, we have our graph with the total cost, and here it's obvious that it's good for the planet, yes, but bad for the wallet, because it really costs more to choose the most efficient products for a same service that has not changed, again, of washing 4 kilos of laundry. If we move on to the dryers, so here we see that it's been a decade that there has been a real progress on the market thanks to the introduction of the heat pumps models. So the heat pumps models are always classed in the A+, and A+++ on the label. However, if we look at national differences, don't look at the numbers, just look at the colors. On the left, you can see the French market, where very difficultly, after a long period of time, in 2019, the good classes make up 37% of the market. And on the right-hand side, you can see what happened in Germany, where the heat pump models make up 85% of the market. So here again, a big difference. If we look at the consumption, though, this is for 2019, we can see that it is worthwhile always to choose a better energy class, because the reduction of energy consumption is really significant. It remains significant. And here the A class is a bit hidden, because there are very, very few models that can fall in this category for a technological reason, because of the technology break that is with the heat pump models. So a final slide is the same, the total cost. Here I'm happy to conclude on the graphs slides with this one, because it is good for the planet and for the wallet to always invest in the most efficient appliance. I make just one slide on the focus, because in France we had the chance to have another project that is called panel Elecdom, where they measure, actually they've been measuring for a year 100 households, and they will continue, which is great. And they have measured 45% more consumption for refrigerators than we have in our sales data. I think this is more or less explainable for refrigerators because of the age of installed appliances that may be older than what the owners actually think, because they include the consumption of independent freezers that weigh quite a lot, and also because of the users' habits, and they are not reflected in the standards. So if people put hot dishes in their fridge, or if they install them near to refrigerators or exposed to the sun, of course the electricity consumption goes up quite a lot. For washing machines, they have measured 57% less electricity consumption, and this can be explained because there is on average less cycles than the hypothesis at European level used in the label, and also the cycles used are less non-standardized cycles, so non-cotton cycles and less hot cycles than what is planned in the standard. For the dryers also, they have measured 30% less electricity consumption, but here we think there is a problem with the sample that impedes to have consistent and coherent data. So as a conclusion, we would say that in a context in which each kilowatt hour counts and cannot be wasted, we advocate for a systematic monitoring based on sales data. And that should be done for Europe as an average, but also per country to highlight the trends and the differences and then investigates on these reasons. Thank you very much for your attention.
So yeah, thank you very much, Sophie, for this very interesting presentation. And maybe you've already seen there are already questions in Zoom chat. And I see the others had the same question as me, how much, for example, electricity prices in the different countries are affecting the results you have presented. I would just add maybe aside to the electricity prices, maybe do you think that also local manufacturer structures are also affecting this? This are also different between national manufacturers. So Sophie, please.
So maybe the electricity prices play a role. We don't know in the details, but for sure we have lower electricity prices in France. So the calculation that retailers can explain in shop is not very convincing, that's for sure. But even when it is convincing for dryers, it doesn't work. Because for dryers, we could show the savings, and however, people do not choose efficient models. So maybe electricity can explain partly, but not everything. I don't think at least it is sufficient. We should make another study. Again, this study is really to put the hypothesis, and please send me your hypothesis and I would be happy to launch as many studies as we have hypotheses. Regarding the local manufacturers, I'm not so sure because there are for these type of products, there are not a lot of local manufacturers. There are some retailer brands, but they make they have their products manufactured in China, and we have seen that some of them position themselves on the very low range and low price, and others can make an effort. That is, they can have low price models that are efficient because they only choose the energy efficiency attribute for these products.
Mm-hmm. Okay, so then I see we have already another question. How complete are the data sets that you can get for long past years? Characteristics that would you like have and GfK did not connect?
No, I think actually JFK is like the Alibaba cave. You could, they have everything. It's just a matter of budget. And then, of course, you have to adapt because the regulations have changed over the years. So we made some calculations to tighten the eventual gaps. Sometimes when there is a change in the norm of the measurement protocol or in the label, we had to adapt. But they know almost everything on these products.
Mm-hmm. Okay, yeah, then thank you very much. I think there's one very last question. We have rough estimation of energy savings due to policy in those countries, how this is linked. So the very last question.
Yes, we have made some assumptions. I don't know all of them by heart. I know only, for example, for France, for refrigerators, it would be 90 gigawatt hour if we would be like Germany. And in general, we saw that Germany is ahead about 6 or 7 years. We could say that France is in the situation of Germany 6 or 7 years back, for example.
Okay, yeah, then thank you very much for the presentation and also for answering the questions. And maybe, yeah, I think there was another question, but you can maybe answer it also in the chat, or we can use the time later on. But with look at the time schedule, we're a bit behind. Then we have now to go on to our next presenter and presentation, which will be given by Kishore Kumar. And Kishore is a senior associate at CLASP India, providing technical support to the government, particularly developing efficiency policies for appliances there. Has over 11 years experiences, not only in India, but also for projects in Brazil and Vietnam. And with focus on India, he will present the impact of refrigerator efficiency policies and on the associated market transformation. So please start the presentation.
Good afternoon, everyone. This is Kishore. Actually, I work as a senior associate in CLASP India office. And first of all, I would like to thank eceee for shortlisting this paper and giving this opportunity to present this. So today, I'm going to present on the impacts of the refrigerator efficiency policy and associated market transformation in India. So moving forward, the people who doesn't know about CLASP, actually our mission is to improve the energy and environment aspects of an appliance that we use in day-to-day lifestyle, and also to support the transition to a sustainable world. So this is our main mission. And with that objective, we actually work closely with 100 countries till now, and currently our policy and the climate work and the clean energy work are focused in various regions in globally. So if you see a graph, like we are currently focusing in China, India, even Southeast Asia, and Africa and Europe, and even South America and Brazil. So this is our currently major focus of work is going on. Moving forward, standard labeling program for appliances, basically developed by the Bureau of Energy Efficiency. It actually launched in 2006, and the Bureau of Energy Efficiency is such a body under the Ministry of Power, and this is actually under the Energy Conservation Act. Yeah, and the CLASP been very instrumental providing the support to the Bureau of Energy Efficiency, and it's been like over a decade that we are working with them closely. And the main objective of a standard labeling program is to reduce the end-use appliances electricity consumption without diminishing service levels, and also to monitor and verify the energy savings of energy efficient appliances. Also to create the awareness to the consumer about the efficient appliances, and also make them informed while buying any energy efficient product, so that they can make an informed decision. Yeah, and with all this objective, the additional benefit is that the scheme also helps to improve the quality of a product. So this is the main objectives of a program. And if you see a sample label of a star label is available in the slides on the right hand side, you can see. So there are 5 stars. So the 1 is the least efficient star, and the 5 is the most efficient star. And whatever the product which complies or falls within the bands are actually get the respective star to be affixed on the appliances. And also additionally, the label displays about the electricity consumption of appliances, and even its validity period of the label, and the model number, the year of manufacture, the refrigerator or the appliance type, and even the other technical information as well. So this is the brief details about the standard labeling program, and also just to give an overview, currently there are 28 appliances registered under the labeling program or covered under the labeling program, and 10 are mandatory and the 18 are in the voluntary phase. So the product that we're going to discuss, the refrigerator, it is in the mandatory phase. So going ahead and with household refrigerator types in India, but before jumping into that, basically the refrigerators are used in domestic applications, especially to store fruits, vegetables, and other edible products, to store them, so that it could be used for a longer duration of the time. And if you see the penetration level or the ownership of the refrigerators in India is currently only 30%. So there is a huge potential to increase the ownership as well in the future. And coming at the types of the refrigerator, there are majorly two types: direct cool refrigerator and frost free refrigerator. So the direct cool refrigerator is, as per the name it indicates, it's directly cools the air circulation within the compartment with a natural convection, and it required a manual defrosting thing. And these refrigerators are available in single and double doors. And as because of the technological constraint, they are used for smaller capacities and small sizes, you can say. And further, or if you see about the frost-free refrigerator type, the frost-free are generally, provide forced circulation or forced convection air circulation within the compartment of the refrigerator, and it does not require any manual defrosting, because there is a inlet fan which supports for circulation and systematically cool the compartment in that. And also this frost-free refrigerator types are used for multiple doors and double doors predominantly, and they are available in larger sizes and which could be used for bigger families as well. So this is a brief about the types of refrigerator. Moving forward, if you see the journey of a refrigerator labeling program since inception, so the frost-free refrigerator actually launched in 2006 under the voluntary scheme, and later in 2007 the direct cool refrigerator got launched in voluntary program, and in 2012 to 2021. Before that, they also become mandatory in 2009. The frost-free, the direct cool refrigerator become mandatory in 2016, and the frost-free become mandatory in 2019. So they also actually got revised during this tenure in 2012 to 2021. The frost-free got revised by almost 5-star levels, and the direct cool got revised by almost 4-star levels. In year 2022, what we is planning is, because as you see, there are two separate refrigerator labeling programs are there in the market. The Bureau of Indian Standard actually came up with a test standard which is common to both the refrigerators, and accordingly, when that is out, the Bureau of Energy Efficiency is also planning to develop a common star rating labeling program. So this is like an overall journey of a refrigerator program. And looking at the revisions of policy, you can see the star rating table for the frost-free in the slides. So if you see the frost-free refrigerator star rating table in 2006 to 2011, there are star rating equations, which includes the KNF and the CNF, which are the constant allowances or the multipliers, which are active values, and then they have been multiplied or with respect to storage or the capacity of the refrigerator. So for the star rating table, you can see the 5-star values are actually got revised or got changed over the period of time, because there is a revision in 2012, 2014, 2016, even 2020. So the 5-star of 2006 actually become a 1-star in 2016, and you can see a similar trend is also being followed for direct cool refrigerator policy as well. And in the lower table, where the 5-star of 2007 level actually reduced or actually revised very stringent to become a 1-star in the year 2020. So this is like a revisions, we can say it. And for the frost free, there was a revision of 5-star level, and for the direct cool, there was a revision of 4-star level over the period of policy timeline. So because of these revisions, this also reflected into percentage improvement of your star level values, where the 1-star of a frost free actually got increased by 67% compared to the baseline of 2006, and currently when you compare it, and for the direct cool refrigerator, it got almost increased by 59%. So this uniform improvement is also observed in other star levels, because the star rating bands, whenever there is any upgradation, which also equally affected the entire star level as well. So there was a uniform improvement among all the bands over the period of time. And going further, talking about the refrigerator market, if you see the graph on the left-hand side, the overall refrigerator market in year 2007 was hardly like 3 million units used to sold every year. But if you see 2019, it has increased to 5 times, that is like almost like 15 million refrigerators sold annually. So this is very drastical improvement in the market, and this could be various reasons, like the middle class income has increased and the economy also got increased over the period of time. So the demand of the refrigerator got increased drastically on that. And if you see the refrigerator market by types, there are basically 2 types. First one is direct cool refrigerator, which actually dominates the market with 80%, and the other 20% is frost free refrigerator. So so this is the market distribution. And sorry, the direct cool refrigerator actually dominated the market since the beginning, like in 2007 till 2019, and that's been a majority of the market share, we can say. And this is a very interesting slide, I would say. So because of this policy revisions over the period of time, how it actually affected the overall market in terms of the star rating levels. If you see the first graph on the left-hand side, the frost free market share in 2011 was almost 60% for 5-star. It actually reduced to 0% from 2014, and even 2019 the market share is very low. So, but at the same time, the interesting fact is, like, if you see the market share of 2-star in 2011 and even the 3-star, they drastically increased over the period of time, where from 3% of 2-star 2011 got increased to almost 57% in 2019 for the 2-star. And the similar trend is also being observed in the direct cool refrigerator also, because the direct cool refrigerator market got revised or increased over the period of time. Where in 2011, the market share of 5-star, it's almost 51%, and it actually reduced to 3% in the year 2019. And if you see the market share of 2-star in 2011, it's hardly less than 0%, but it over the period of time, it actually increased to 36%. And you can see even for the 3-star also, the market share has increased drastically. So the higher star, like 5-star, 4-star market came down, and the 2-star, 3-star market actually increased over the period of time. So this is like a kind of a market transformation, you can say, due to the revision of the policies. And also because of the revision of the policies and the stringencies, it also resulted into reducing the electricity consumption of an average refrigerator in the market. If you see this graph, which actually says, like in 2011, for the frost free, which is like a blue-gray line, which used to consume approximately 400 electricity units in 2011, which actually reduced to 250 units, in the electricity. So it means actually 39% of the electricity consumption has been reduced compared to the baseline, and this trend is also observed in the air-cooled refrigerator as well, where the electricity consumption used to be close to 300 units in 2011, reduced to close to 190 units in 2019. So there is like a reduction in the electricity consumption by 34%. So this is because of another policy revision and the market transformation, you can say. And going forward, if you see, this is all of the models which are registered right now with the Bureau of Energy Efficiency, close to 200 of them, and you can see that the direct cool refrigerator models are less and frost-free are more. So at the same time, the direct cool refrigerator consumptions are less and frost-free consumptions are more because of the different capacities or higher capacities. But when you compare these models with the models which used to be there in 2010 or 11, they're drastically very low. So you can see the models which are available in the market, they are most energy efficient comparing with the earlier models, and we also learned that this is because the manufacturer started adopting the energy efficient technologies and the methods which actually resulted into the efficient products. So those are like using the BLDC motors and inverter compressors and even the better insulation. So this has been the reasons for having the efficient refrigerators currently, you can say. And finally, if you say what are the major impact of the refrigerator labeling program in terms of the electricity savings and the CO2 emission savings are shown in this graph or slides. So since the inception of the program till 1920, the overall electricity savings cumulative being for the both direct cool and frost-free is 167 terawatt hour of electricity savings, which is like a very huge number, and also this the CO2 equivalent reduction being is approximately 137 million tons has been reduced, or the CO2 emission has been avoided, you can say. So this is one of the major impact of having a labeling program, and because of this technology and the market size, when you compare the savings with the other appliances as well, refrigerator is the one which actually resulted to have a most energy savings compared to the others. And moving forward, or conclusion and the recommendations, as we all know, it is necessary to have policies to standardize the market and to regulate it, to have a energy efficient products. But at the same time, the other side of the coin is like it has a market barriers which includes like higher upfront cost of the product and the limited availability in stores, low consumer awareness, and the limited advertising. So to address that, we are recommending to have a market transformation initiatives which actually promotes usage of the efficient refrigerator in the higher star category, or focusing on the 5-star refrigerators, because you can see the market share of the 5-star is very less. So it is very important to promote the 5-star refrigerator. So to do that, we are recommending to have a replacement program for refrigerator with old inefficient refrigerators could be replaced with the new and efficient ones, and at the same time we should have a bulk public procurement for the efficient refrigerators. And also to promote further, it's always good to have incentives to the consumers and even to the manufacturers to promote the 5-star refrigerators, you can say. So this is all our recommendations and the conclusions of our presentation. I hope you all like the findings and the impacts on the market transformation. If anyone have any questions or queries, I'll be happy to answer. So this is all from my end. Thank you very much. And
yeah, thank you very much, Kishore. And actually, as you offered, there are already some questions, and I think you can already see them in the audience. I repeat them also, because first question was, did you see an effect of the policy on the purchase price of products, maybe the total cost of ownership? That was the first question.
Yeah, thanks, Thomas, and it's a great question, Eva. So the first thing, like on the policy impact on the purchase effect, as of now at the BE, what are the data that we actually conduct analysis in the presentation are being available at the BE side, but not much on the cost, because at right now we are only getting the production information from the manufacturers, not the sales data. So as you know, generally the manufacturers have the MRP, which are called manufacturer retail price, where by end of the day the dealers in the ground level may sell the price which are even very low, that we are not even able to track it, because even the manufacturers are not able to track it that. And also we have like an online portal like Amazon and Flipkart, where they do provide offers, so to encourage consumers to buy it. So the getting track on the purchase price is very difficult, and at this moment, and we also planning in the future to focus that overall cost because of the policy impacts that we will maybe take up in the next study or whenever in the future. So that's for the answer to the question. Yeah.
Okay, and thanks. And then there's other two questions already at least, and I'm have to see, because this changed the order. Tina's question first, I read. From your kilowatt versus volume graph, it looks like there's a lot of efficiency potential still for both types of refrigerators. Anything different here in future policies to achieve these savings, or should India just continue the current successful strategy?
So basically, I'll be very honest. If we share this, we actually share this information with manufacturers about the energy consumption, all of that. If you see in the slides, the 5-star market is like completely zero. So the efficient technologies, they're saying currently they're very limited, and the India labeling program is one of the stringent to their understanding compared with other countries. So as of now, we don't have any analysis of findings which actually compare the India with other countries, which is justifiable because every country has a different metrics and different test conditions. So the normalization factor is not it's not been set or standardized yet. So we have to have those findings results, and on the potential improvement in the future, because currently India going to adopt the new test standard, which is almost similar to the IEC test standards. So we are trying to develop those framework and understanding the overall impact on our labeling program, and then accordingly we will plan the revisions in the next 1 or 2 years based on the technologies availability, and we also see what is the what is the energy consumption with respect to international standards, because right now we're going to adopt the IEC as well, so we can do an easier comparison, I would say. So this is what my answer to that. Yeah.
Mm-hmm. Okay, thank you. And then we have also a third question, and it's related to the revision cycle, because in India, this every 2 or 3 years, compared, for example, to the EU, where labels and maps are typically revised every 5 to 10 years sometimes. And the question is it accepted with manufacturers and dealers? And is there any intention to update these frequent update cycles, or is it intended to be continued?
So to be frank, that's a great question, and even the manufacturer have that similar question to us, that why you want to revise only every 2 to 3 years. So I would say in last 6-7 years or before that, the India labeling program was maturing slowly, step by step, and during the course of policy revisions, we learned that revision of our policies for every 2 to 3 years actually gives a payback to the manufacturer, whatever the investment that he has put up for the change in the production line and everything. So that is one of the reasons that we've been trying to revise this label program every 2 to 3 years. And also we see the consumers' acceptance in India on the revision is quite well, and they are also supporting. And we also see a great benefit for the revising in every 2 years because of the energy savings coming out from that. And coming back to the manufacturers, like, do you want to continue the 2 to 3 years revision cycle, or you want to make it 4 to 5 years? So what we understood is like, the mandatory products which are launched like 10 years back, the BE has revised extensively, which made the technology mature, or they even comparable to the international standard. So so in the future, or we already started for air conditioner, instead of revising for 2 years, we actually make it revising for 4 years. So that trend has been started for few mandatory appliances, and we take that decision based on the consultation with the manufacturer, with the technical committee meeting before any revisions. So the revision will differ from product to product and from mandatory to voluntary product. We will take that revision cycle accordingly in the future. Yeah. So that's my answer.
Okay, yeah, thank you very much. So I see we have no further questions at the moment, and we are already more or less approaching the end of our session time. I'm just looking, I think there was another discussion, but it was not for you, Kishore. It was only internally for the other. Therefore, thank you very much, Kishore, for your presentation, all the other presenters also. And then I would like also to make a short advertisement. We have another session in panel 9, starting about half an hour from now, on product regulation and related effects. So we would be happy to see you there again. And for the time then, have a short break, and looking forward to see you again. Thanks again to all, and all presenters and all attendees, and see you later on. Bye-bye.
Thank you, guys. Bye. Take care.
Thank you very much. Bye-bye.